Hello and welcome back to a new course and a new session, and this time it will be in data interpretation. In this course, we look at concepts, key concepts involved, and calculation tips and techniques also. Okay, so let's begin. And the idea number one in data interpretation, a very commonly used idea is growth rates. Okay, so let's begin with understanding what a growth rate is. So a growth rate is the percentage change between the new value and old value while considering the old value as base. Or in other words, by what percent is the new value more than the old value. Okay. Growth means change and growth rate becomes rate of change expressed in percentages. As you can already see, percentages or understanding percentages is going to be very integral to data interpretation. Okay, so make sure that you've gone through the percentage courses and the ratios course, because ratios and percentages will be used interchangeably a lot. We'll be also using multiplying factors. If you do not know what multiplying factors are, it is recommended that you go back to the percentages course and understand how they work. Okay, we keep repeating the basic ideas, but if you understand percentages and ratios, life would be very easy as we move along. Okay? So back to the growth rate. Growth rate is nothing but the percentage change between the new value and old value while considering the old value as base, or by what percent is the new value more than the old value. Growth rate is the rate of change expressed in percentages. Life becomes easier when we use an example. So let's begin with a very basic data. Let's say my salary in the year 2006 was 35,000 and my salary in the year 2007 was 42,000. And the question is, what is the growth rate for the salary in the year 2007? Okay. You can interpret the questions for your own language. So basically the question is 42,000 is what percent more than 35,000, okay? Or the growth, that is the difference between 42,000 and 35,000, is what percent of 35,000, okay? So we can see that the growth is 7,000. It has gone from 35 to 42. And my question was growth rate. That means I want to express this as a percentage of the old value or the base. So 7,000 as a percentage of 35,000. That means 7,000 in the numerator and 35,000 in the denominator multiplied by 100. The zeros get cancelled. I get 7 by 35, which gets reduced to 1 by 5. And then 1 by 5 into 100 gives me 20%. So my growth rate for the salary in the year 2007 as compared to 2006 was 20%. Okay, so I hope that made sense. Okay, so from the specific example, if I want to generalize the formula, uh, all the data is there. I will call 35,000 the old value and 42,000 the new value. And I see my growth rate was 7,000, which was the difference between 42,000 and 35,000 divided by 35,000. If I replace the tags there, the values become new value, old value, new value minus old value upon old value into 100. Okay? So that would be my general formula for growth rate. New value minus old value divided by old value. You can also call it final minus initial upon initial, or you can also call it later year minus the previous year upon the previous year into 100. Okay? It is worthwhile to drive home the point that most of data interpretation is nothing but ratios and percentage applications. Okay, so in that regard, let's try and reinterpret this question in percentage terms. Okay, so the question, what is the growth rate for the salary in the year 2007, is same as asking salary in 2007 is what percent more than the salary in 2006. Or if you want to change the language further, by what percentage should the salary of 2006 be increased to reach the value of 2007? Okay, this is just to show you the same idea over and over again, that working on your ratio and percentage skills will pay off in DI, data interpretation also. Okay. Another part of success in data interpretation is calculation and speed in calculation. And remember, speed comes from a little bit of repetitive practice. Okay, so in that regard, we'll try out a few examples. We know the idea now. Our formula for growth rate is new value minus old value divided by the old value into 100. So let's try out for these numbers. Okay, so let's say there are 5 people and their salaries are given for each year, and you're supposed to find the growth rate. Okay. So I'll begin with finding out the difference for each, and I'll put them in the numerator and denominator form and multiply by 100. Okay. So for the first person, the difference is 700,000 divided by 350,000. So that zeros get cancelled. I get 1 by 5 into 100, that is 20%. For the second person, it is going to be 4,500 divided by 18,000. Cancel the zeros, divide by, you use 9 and cancel for 5 and 2, and then it becomes 1 by 4. You can try the calculation on your own in case you're not following me. So 1 by 4 into 100 gives me 25%. Okay. For the next one is going to be 45,000 divided by 4,50,000. This should be an easy calculation. It cancels out to 1 by 10. So 1 by 10 into 100 gives me 10%. Okay. For the next one is going to be 20 upon 140 into 100. So the zeros get cancelled and I get 1 by 7. And 1 by 7 into 100 you can calculate on your own. Please do the calculation so that they start sticking in your head. 1 by 7 is 14.28%. I've simply divided 100 by 7. Okay. For the next set of data, it's going to be 200 divided by 3600. The zeros get cancelled and I get 1 by 18. 100 divided by 18 gives me 5.55. So my answer would be 5.55%. Okay. So what we're trying to do is nothing but repeat the idea that the growth rate is new minus old divided by old into 100. What we also saw in this process is that the numbers could be of very different scales on a very different variety, but in each case after the calculation it gets reduced to a very basic reciprocal. I got 1 by 5 and 1 by 4 and 1 by 10 and 1 by 7 and 1 by 18. So the idea would be that if I can spend some time, a very limited time, on trying to memorize these reciprocals from 1 by 1 to 1 by 30, my calculation speed would be much faster, because I won't have to do these calculations, basic calculations, all over again. So it's like having this in your quick access memory all the time. You should know these numbers by heart and you will see a change or an improvement in your speed and calculations. Okay. So now what we'll do is we'll go through these reciprocals one by one. Also keeping an eye on how to remember them. We'll be using a concept called grouping or chunking. So from reciprocals from 1 by 1 to 1 by 30, we'll divide into small groups which are somehow connected. Okay. So a very easy group would be to start with 1 by 2. 1 by 2 is an easy enough number. It means 50%. 50 by 100 is the same as 1 by 2. Okay. Now I'll just start dividing by 2 on both sides. So 1 by 2 divided by 2 gives me 1 by 4, and 50 by 2 gives me 25. So it's a very easy enough calculation. That means if I remember 50% or half as 50%, remembering 1 by 4 as 25% is not too much of a problem. Okay. 1 by 8 would be 12.5%. Same logic, divide both sides by 2. Keep following the process. So 1 by 16 would become 6.25%. 1 by 32 would be 3.125%. You need to have these numbers in your memory, like totally ingrained, seared into your consciousness. Okay. And this would be the process. I will start with 1 by 2. I will do it a few times. I go from 50 to 25 to 12.5 to 6.25 to 3.125. Okay. We should also remember a few multiple of these common reciprocals. Okay, so I know 1 by 4 is 25%. What would be 3 by 4? Now 1 by 4 is 25, so 1 by 4 into 3 would give me 75%. Okay. Similarly for 1 by 8, 1 by 8 is 12.5%. A few more reciprocals that I should remember are 3 by 8. 3 by 8 is 37.5. 5 by 8 is going to be 62.5. And 7 by 8 is going to be 87.5. Okay. All I'm doing is multiplying 12.5 by 3, multiplying 12.5 by 5, and multiplying 12.5 by 7. Okay. And I get these values. It's not only about memory, it's also about being able to calculate these numbers. Okay. So for example, one would not expect you to remember, let's say, a fraction 3 by 16, but I know 1 by 16. So how do I go about calculating 3 by 16? It should be fairly easy. 3 into 6.25, 3 into 6 gives me 18, and 3 into 0.25 gives me 0.75. So my value would be 18.75. What I'm also doing here is, while multiplying, instead of using pen and paper, I'm breaking down the number. So I had to multiply 3 into 6.25. I'm not doing the standard multiplication method of writing down the numbers and multiplying them one by one. I'm multiplying 3 by 6 and then multiplying 3 by 0.25. Both the calculations are fairly easy. I can do it in my head, and that again can add up to a little bit of speed. Though, if you're not comfortable with this, I would suggest that you stick to your standard method of calculating whatever works for you. Okay. How about 5 by 16? Okay, just some practice. So 1 by 16 is 6.25. 5 into 6.25. So I will again break it down. 5 into 6 is 30. And 5 into 0.25 is 1.25. So my answer would be 31.25. Let's do more practice. 7 by 16. Once again, 7 into 6.25. 7 6 are 42. And 7 into 0.25. Okay. Again, if you want to just start thinking and make your life easy, 8 into 0.25 would have given you 2. And it is 1 of 0.25 less than that. So I'll get 1.75. So I had 42, 7 into 6, 42 earlier. And 7 into 0.25 gives me 1.75. So 42 plus 1.75 gives me 43.75. Okay. What I'm trying to show you is that make your calculations easy for yourself, break down the numbers, and maybe you can start doing things in your head instead of using or reaching out for pen and paper every time. I leave this practice to you. Calculate 11 by 16 for yourself and try. You can directly multiply 11 into 6.25, but just for practice sake, I would suggest multiply 11 into 6 and then 11 into 0.25 and then add them up, and try and not use pen and paper. Okay. A little bit of more practice. What is 3 by 32? So it will become 3 into 3.125. Again, to make it easier, I will do 3 into 3 and then 3 into 0.125. Okay, so 3 3s is 9 and 3 into 0.125 would be 0.375. So my answer would be 9.375. Okay. So I should have some of these core fractions in my memory, and the other ones I should be able to calculate pretty quickly. You can practice with 5 by 32, and or you can create your own reciprocals and practice with them. Okay. Moving on in the group structure. So we are looking at the group of 1 by 2 and 1 by 4 and 1 by 8 and 1 by 16 and 1 by 32. Let's start with 1 by 3 this time. So 1 by 3 is 33.33%. I mean, multiplying something by 1 by 3 is the same as multiplying it by 33% or trying to find 33.33% of it. Okay. I'll follow the same process as last time. Divide both sides by 2. So I get 1 by 6, which is 16.66%. Further dividing by 2, I get 1 by 12, I get 8.33%. Again divided by 2, I get 1 by 12, which is 4.16%. So again, do this process in your head a couple of times. Start with 33.33% and move up to 4.16%. Also notice the pattern that whenever you're looking at these multiples of 3 in the denominator, there is a recurring pattern in the number 33.33, 16.66, 8.33. And as usual, also think of a few multiples. So if I have 1 by 3, what would be 2 by 3? 2 by 3 would be 2 into 33.33, which is 66.66%. Okay. What would be 4 by 3? Because it is not necessary that when you're calculating that your numerator will always be smaller than your denominator. It could be more than the denominator also. So in that case, the answer is 133.33%. How? 1 by 3 is 33.33. 33.33 multiplied by 4 gives you 133.33. Or what you can also do is think of 4 by 3 as 3 by 3 plus 1 by 3. Okay. Now 3 by 3 is 100%. Any number by number is always 100%. Plus 2 by 3, and I know 2 by 3 is 66.66%. So, 1 by 3 is 33.33%. So 100 plus 33.33 would be 133.33%. Let's try the same thing with 5 by 3. 5 by 3 is 166.66%. You can directly multiply 33.33 into 5, or you can split the fraction into 3 by 3 and 2 by 3. 3 by 3 would become 100% and 2 by 3 would become 66.66%. Add them and you get 166.66%. Okay. Similarly, what is the value for 5 by 6? 1 by 6 is 16.66%. You can multiply 5 into 16.66 and you can get to the value of 83.33. Or you can think of 5 by 6 as 6 by 6 minus 1 by 6. 6 by 6 is 100%. Minus 1 by 6 would be 16.66%. If you subtract it, you get 83.33. Okay. Even for calculating 5 into 16.66, if you're finding it difficult, I can split it. I can say 5 into 10 is very, very easy. So that becomes 50. 5 into 6 is very, very easy. That becomes 30. So far I've got 80. 5 into zero point 0.6, I just calculated 5 into 6 and I am now doing 5 into zero point 0.6, only a decimal is shifting. So instead of 30, I'll get 3. I had 80, I had added 3 to that, so I get 83. Once again, I'm multiplying 5 by 0.06. So last time I got 3, this time I'll get zero point 0.3. So my final answer is 83.3. Okay. If you're comfortable directly multiplying, please continue doing so. This is just one way of thinking. This is all the methods are equal to each other as long as you master them and practice and repeat, so that you develop speed in that particular method. So whatever works for you, just practice with that method. Okay. I will leave these calculations for multiples of 1 by 12 and 1 by 24 to you. Okay, moving on. Let's look at the cluster of 5 or multiples of 1 by 5. 1 by 5 is very, very easy. 1 out of 5 is the same as 20 out of 100 or 20%. Yeah. If I divide that by 2, I get 10%. If I further divide that by 2, I get 1 by 20 as 5%. Okay. Now, 1 by 25, we know that 1 by 4 is 25, so 1 by 25 would be 4%. You can just move the numbers around and you can see that. Or you can divide 1 by 5 and you can get 1 by 25, which is 4%. Okay. Also, as usual, take your time to think of the multiples also. You have 1 by 5 and then that is 20%. So 2 by 5 would be 40%, 3 by 5 would be 60%, 4 by 5 would be 80%, and 5 by 5 would be 100%. Okay. Multiples of 1 by 10 would be very, very easy. Let's say we have 4%, but you want the multiplying factor for 12%. Okay. So using 4% is 1 by 25. 12% is 3 times the 4%. Therefore, 12% would be 3 by 25. So be ready and willing to do such kind of calculations, and you will see drastic improvement in your speeds. Okay. Uh, the odd one out in multiples of 5 is the third multiple, which is 1 by 15. The way to remember it would be the value is obviously 6.66%. The way to remember, the key to remember it would be that in Western mythology, especially in horror movies, this 666 is the number of the devil. Okay. Because we're trying to not only remember these, figure out these numbers, but we're also trying to group them and figure out techniques of remembering. Whatever works for you, that's how I remember it. Plus, it's a little bit of trivia also to keep your mind engaged. The 666 is the number of the devil. So, this is the cluster of 5. Now, the other ones, the slightly difficult ones, 1 by 7 is 14.28%. How I remember it is it's 7 twos are 14 and 7 fours are 28. So, whatever is the percentage is a multiple of the denominator. So, 1 by 7 is 14.28, and the key to remember is 7 twos are 14 and 7 fours are 28. Okay. Divide that by 2, you get 1 by 14, so that is 7.14%. Again, to remember it, 7 is half of 14 and 14 is 1 time of 14. Okay, so again as a multiple of the denominator. 1 by 28, you can divide 7.14 by 2 and you can get 3.57. The key to remember it would be that 3, 5 and 7 are all prime numbers. So these are prime numbers in succession. Okay. The next cluster to look at would be a very interesting one, a very good symmetric pair, which is 1 by 9 is 11.11%. And if you take the opposite of that, you get 1 by 11 is 9.09%. Okay. Make sure you remember these two. Very, very easy to remember also because of the pairing. Okay. Also think of the multiples because they cover a lot of multiples. Okay. So for example, if 1 by 11 is 1 by 9 is 11.11, 2 by 9 is 22.22, 3 by 9 is 33.33, 7 by 9 would be 77.77. So wherever you see these repeating numbers, you know in the denominator there is going to be a 9. Similarly, for 1 by 11, the multiples are 2 by 11, 18.18, 3 by 11, 27.27. Again, there's a pattern there. The digits, the numbers are repeating. There, the digits were repeating. Here, the number repeating. So 27 and 27, 36 and 36. So you know in the denominator, there is 11, or basically 9.09 is being multiplied by various multiples. Okay. So moving on, 1 by 9 and 1 by 11 we know. Now 1 by 18 is going to be half of 1 by 9, which is 5.55. Now dividing 11.11 by 2 and remembering is okay, but then 555 is also, I think, a very famous brand. I don't remember which brand particularly, but I'm sure you can find it out. So 1 by 18 is a brand, so maybe you can associate it with that brand. So 1 by 18 is 5.55. Similarly, dividing 1 by 11 by 2, we get 1 by 22, which is 4.54%. Okay, probably you can label this also as a brand, 454, just like 555 could be a brand, 454 could also be a brand. Remember, these things are not very important. It's just important that you remember these reciprocals. These are my excuses and my ways of remembering these small things. Okay. Okay, another interesting group is start with 1 by 20. We know it's an easy enough number, is 5%. Now move to 1 by 19 and you get 5.25%. And move to 1 by 21, you get 4.75%. Okay, the pattern being that the numbers, the values are increasing and decreasing by 0.25 and 0.25. And 0.25 itself being a square of 25 being a square of 5. So that could be a way of remembering it. A very similar pattern. It's worthwhile because the same kind of thing works for 1 by 25 also. 1 by 25 is 4%, and if I move to 1 by 26, I get 3.84%, and if I go to 1 by 24, I get 4.16%. Once again, the values are increasing and decreasing by 0.16, or 16, which is the square of 4. So there is some pattern here which can help you remember this information slightly more in an easier fashion. Okay, now the completely odd ones out, which are not, not connected to big chunks, but maybe we can connect them together. 1 by 23 is 4.35%. Maybe the way to remember it could be that it has all the numbers, like it has three consecutive numbers, 3, 4, and 5, just that the orders are different. Okay. You can relate it to 1 by 29, which is 345%, which is again easy. The numbers are in sequence. So maybe you can pair 1 by 23 and 1 by 29 together, and the value could be 4.35%. Okay. Okay. So the last odd one out here is 1 by 30. Now the value is 7.69%. We'll round it off to 7.7%. Now, 13 is again considered in the Western mythology is considered to be an unlucky number, Friday the 13th, etc. Now, have you ever played this game called Tambola or Housey? In that, when the person takes out the number 77, they often say lucky number 77. So, if you take the reciprocal of 13, which is an unlucky number, it becomes the lucky number 77. So, just another way of remembering it. By the way, this story is not really true. I'm sure you have played Housey, and 77, I'm not sure it is called the lucky number, but that's how you can tell yourself and help yourself remember. Okay? And lastly, 1 by 17, another lone number, difficult to pair it with other numbers, but the value is 5.88%, and the way to remember it would be 17 5s is 85, and flip it and it becomes 5.88%. That's the best I could come up with for this number. Okay. So take your time, go through the whole story again, write down these numbers a couple of times from memory, repeat for a couple of days, and you will remember them as well as anybody else. Okay, and you will see that when you are calculating these percentages and ratios, they will come in very handy and help you do your calculations faster and quicker. Okay, so now let's apply this in an example, the same growth rate example. Okay. So let's say the salary in the year 2006 was 852 rupees, and the salary in the year 2007 was 1506. And the question is, what is the growth rate for the salary in the year 2007? And this time options are given, and this is what we'll be doing. Instead of doing detailed calculations, We'll be using approximations, fractions, and the help of options to come to our answer without actually calculating the whole thing. Okay, so let's try it out. We have to find the growth rate. That means I have to find the difference, that is the new value minus the old value. So 1506 minus 852 divided by 852 into 100 is going to be my answer. Okay, so that much I have to do whatever method I use. So it's going to be 654 divided by 852. Okay. Now what I'll do is I'll ignore the 2 and the 4 at the end, and I'll think of these numbers as 65 and 85. Okay, I'm just forgetting the number at the end. Okay, so this I can simplify 65 by 85 as 13 by 17. So broadly this number is somewhere close to this fraction 13 by 17. Okay, we do not want to do the whole calculation. I'm at least hoping that's not the purpose of the exam, to make you do a lot of calculations. So you come to a general range or a point where you know the answer is going to be close to. So it's going to be 13 by 17. Let's work on the value of 13 by 17. I know 1 by 17 from just now is 5.88%. Okay, so now 13 by 17 I can calculate as 13 into 5.88. Again, try to do it in your head. The way to do it would be do 13 into 5, which is 65, and then do 13 into 0.88. Okay. Another way of thinking would be that consider 17 by 17, which is 100%, and from that subtract 4 by 17. This might be an easier calculation. So 4 by 17 would be 4 into 5.88, which would be 23.52. Please do the calculation on your own also. Okay. So 100 minus 23, I get approximately 77, a little less than 77, a little more than 76. I can see that only one answer is close to what I am getting. So my answer is going to be 76%. Okay. Now in this case, this kind of approximation was perfectly alright, because both the numbers ending at the end, the numbers I was ignoring were pretty small, so they wouldn't make a huge impact in the answer. But normally people would do the calculation to the last digit. The point being made is that is not necessary. The options and generalizations will help you to come to your answer quickly. Okay. Another way of looking at the same calculation, let's say, the method is decimal shifting. Okay. So the number is 852, and let's say we have to find 85% of 852. Okay. So what I'll do is I will call the number, I'll just call it n for easy labeling. So let's say 100%, if I ask you to find 100% of the number, the answer would be 852. Okay. Now if I ask you to find 10% of the number, again finding that is very, very easy. All you have to do is divide the 100% by 10, so you get one decimal point shifted to the left. Okay. So you get, instead of 852, you get 85.2. All you have to do is place a decimal from one number from the end. Okay. Similarly, if I were to find 1%, the decimal point will shift by one more. So I have 852, 10% is 85.2, 1% is 8.52. If I ask you to find 0.1%, your answer would be 0.852. Okay. So now these points, this 10% and 1% point, give me a pretty good reference area or a boundary kind of a thing from which to think of my numbers. Okay. So let's say if I now were to find 5% of the number, I can think of it as half of 85.2, which is again fairly easy to calculate. Half of 84 is 42, so this would be 42.5, and 0.2's half is 0.1, so 42.6. Yeah, similarly, if I were to find 20%, it would be fairly easy. All I have to do is multiply 85.2 by 2, so that would give me 170.4. So I hope you get the idea. This is another way of thinking about numbers without doing the whole calculation. So now, if I were to find 85%, I would think of it as 80% of n plus 5% of n. 5% I can calculate as 5 times 1% of n, and 80% I can calculate as 8 times 10% of n. That 5% I can also think of it as half of 10% of n. Okay, so again, I'm leaving the calculation to you in this case. Okay. So now let's apply this idea with the same numbers that we were using earlier, that is 654 by 852. The way to work it is look at the options and think of somewhere in the middle. Okay. So let's say start by finding 75%. Why? Because if I find 75% and let's say it's close to 75%, I can mark the answer. Or it will at least tell me that I have to move ahead in the option. That means I have to move towards 80 or 82. or I have to reduce my value towards 71 or 65. So whenever there are options, think of a middle value and start from somewhere there. You could have started from 70% or 80% also. I'm just starting by 75%. Okay. So 75% is 70% plus 5% of n. 5% is half of 10% of n, or 5 times 1% of n. So 7 into 85.2 gives you 596.4, and half of 10% of n, or 5 times 1% of n, gives you 42.6. If you add these two together, you get 639. Okay. Now what you do is, you wanted 654, right? That exact answer is in the numerator is 654. You've got 639. That means you want to move ahead. That means you have to go above 75%. Okay. But again, how much above? Because there are multiple options, 76, 80 and 82. So how far do you have to go from 75? Again, think how far is 654 ahead of 639, and the value is 15. Now, this 15 as a percentage of the denominator, right? 852. So 1% of n, compare it with 1%. 1% is 8.52. So 2% would be around 16 or something. It is less than that. That means this 15 is less than 2% of 852. Okay, that means there's not too much movement from 75. Again, I can come to the answer 76% pretty easily. Now, these answers answer options might seem very far away from each other, but there will always be some distance between these percentage options. Okay, make sure that you start with a middle value and try and approximate your way to the correct answer. You can of course use the whole calculation and figure out the exact value also if you're. Okay, so let's go back to the concept once again, the growth rate concept, and look at the same data that we looked earlier, but this time change the question slightly and say, let's say for the year 2007, which individuals have shown the highest and the lowest growth rates in their salary. Okay? So this time the question is not for exact value, but finding out who is the highest and who is the lowest in terms of percentage gain. Okay. So what I want to do differently this time around, and especially if you are clear with your percentage concepts, is I do not want to find the difference this time around. I just want to find the new value by old value fraction and its value. Okay. We'll see what it means. Let's start doing that. So let's say for the first individual, that is A, let's call him A, the numerator would be 42 lakhs and the denominator would be 35 lakhs, or 42 by 35. I can simplify it into 6 by 5, which becomes 1.2. Okay. So the numerator by denominator, or the new value by old value fraction, is 1.2. You can also say the multiplying factor for the old salary, that is 35 lakhs, is 1.2 to get to 2007 salary. That is, if you multiply 35 lakhs by 1.2, you will get to 42 lakhs. Okay. So I hope you can connect it with your percentage learnings earlier. Okay? So I'm just doing that. I'm not finding the difference. I'm finding the new by old value. That is the multiplying factor, or you can call it the ratio for the new by old value. Okay. Let's look at the second piece of data. So in that case, it would be 22,500 divided by 18,000. If I simplify it, it will become 5 by 4 eventually, and 5 by 4 becomes 1.25. So the value of this ratio is 1.25. Okay. Try it for the third one. It's 4,95,000 divided by 4,50,000. If I simplify it, it becomes 11 by 10 eventually, or the value of the fraction becomes 1.1. Yeah. Similarly, for 160 by 140, it becomes 8 by 7, and the value of 8 by 7, if I calculate, it becomes 1.1428. Lastly, 3800 by 3600, the value becomes 19 by 18, or the exact value becomes 1.055. Okay, so we've got the data now, but the subject is called data interpretation. So let's interpret what these numbers mean. So let's look at the first pair, that is 35 lakhs and 42 lakhs, and the new by old fractions value is 1.2. What does it mean? It means that when you take 35 lakhs and multiply it by 1.2, you will get to 42 lakhs. Okay? Or 42 lakhs is 1.2 times 35 lakhs. Okay? That means the multiplying factor to go from 35 lakhs to 42 lakhs is 1.2, and 1.2 is nothing but 120 by 100. That means 42 lakh is 120% of 35 lakhs, or 42 lakhs is 20% more than 35 lakhs. So in this 1.2, the moment I see this 1.2, I know that there is an increase of 20%, or the new value is 120% of the old value. I can try the same process for the others. When the value is 1.25, that means 18,000 should be multiplied by 1.25 to get to 22,500, or 22,500 is 1.25 times 18,000, or 22,500 is 125% of 18,000, or 22,500 is 25% more than 18,000. Uh, let's shorten the process for the next one. 1.1 would simply mean that 4,95,000 is 10% more than 4,50,000. Okay, or 4,95,000 is 110% of 4,50,000. The same thing for other numbers also. So that means all I have to do is look at this value after the decimal point and see which is the highest and which is the lowest, and my task would be done. Okay. So you don't necessarily have to find the difference of values. You can just do new by old, and you can still get to whatever kind of answer you're looking for. Whatever interpretation is required using these fractions or these values, you can reinterpret the answer back from. Okay. Okay, that's it for this first session, part one and part two. In the next session, we'll look at more applications of growth rates, ratios, yields, market shares and market values, and more calculation tips and techniques. Thank you and see you soon.